All right, for our first problem today, we're going to use the Desmos graphing calculator to help us make the scatter plot of the data. We're going to do the linear regression to get a little practice with that funny looking equation. And then we'll also use that to make a prediction here at the end. So what we have here is a table that shows the lengths and corresponding ideal weights of sand sharks. So what we're going to do is we are going to start with making our scatter plot. So to review some of the steps, we're going to go to desmos.com. And you can see I still have data here from that baseball experiment with the strikes and the pitches. So I'm going to show you how to clear this quickly. And it's better than just going to delete all, because that's going to cause some problems. It might make the next table x2, y2, and then you have to use x2, y2 down here. And I think it just creates more problems than what you want. So I'd recommend going to the 3 bars and hit new blank graph. Okay, that'll clear everything. Okay, I would always recommend to do that when you start a new problem. So we want to enter a table, so we hit the add item button, we click table, and we're going to enter our data. So I'm going to go ahead and minimize this and see how I'm just kind of moving things around so I can see my data. It's a little trick you can use. Now, one thing that's different here is my table in Desmos is always going to go down. It's going to be a vertical table. My table on my presentation is a horizontal table. So I have to remember that the top row is my X, the bottom row is my Y. So when I type things in, 60 is my first X, 105 is my first Y. Okay, and again, you can just hit tab to move to the next item. So let's see, 64 for a length is 124 for the weight. 66 for a length is 131 for the weight. 68 is 139. A length of 70 is a weight of 149. A length of 72 is a weight of 158. The other thing I would strongly recommend is just do a real quick glance at all of your data. Make sure you didn't mistype anything. It is really, really easy to hit the wrong number on here, and it makes a big difference on your slope and your y-intercept later. So take the extra 10, 15 seconds, just double check your data and make sure everything looks okay. All right, so my table looks fine. I don't see any of my data though, because my numbers are, pretty big compared to what I see here on my X and Y scales. So I hit this little zoom fit button, the little magnifying glass. It's going to zoom me out, and look at that. Those dots, they almost line up perfectly. So this is a very strong correlation here. And I want you to think about what type of correlation is it if my data looks like this? Hopefully you said positive, because you'd be right. It is a strong positive correlation. Strong because those dots really line up. They almost look like they form a line, like if you were plotting a line on a graph. But it also looks like it's very strong because they're close together. Okay, so the next thing we want to do is we want to actually get that line of fit drawn on here. And to do that, we perform that linear regression. So we go and we click in the second box. And do you remember what that equation looked like? It was kind of like y equals mx plus b. So if you want, you can start with that. Okay, and there's 2 things we have to change. We have to change the equal sign to the squiggle. Okay, so I'm going to delete or backspace on the equal sign, get rid of it. I'm going to hold down the shift key, and then I'm going to press the squiggle button, which is right next to the number 1. Okay, it's as far left as you can. It's right below the escape key on your keyboard. I wonder if it's actually even in here too somewhere. Right there. You can even get it on your keyboard too. So I opened up my on-screen keypad. I clicked A, B, C, and that's in the bottom row. It's this one right here. Okay, so if I actually use that, yep, there we go. It works. So you can do that as well if you're worried about finding it on your keyboard on your Chromebook. Okay, and you're like, wait a second, it's not giving me all those numbers that it did in the other video. And that's because we haven't identified that it's X1 from my table. So just after the X, you press 1, and notice it makes it a subscript, and Y1. So we have to change that also. There we go. Look at that. It gives you a nice line of fit. We can see how nicely it matches our green dots, our data, and then it gives us everything we need to know here. our R value, not R squared, we don't really care about that. We care about just the regular R, is 0.9992. That is extremely close to 1.0. So this is a very, very strong positive correlation. We can see that we have a slope of about 4.35714, and our y-intercept is actually negative 156.143. So we could type in our equation, just typing in those exact same numbers. So y equals, and we put the m with the x after it. And I could put plus negative 156.143, but I know that when I add a negative, it's the same as subtracting. Okay, so if I take this other line away, I see that my line of best fit appears there on the screen. All right, so there's my equation. And minimize that for a second. Because now what we're going to do is we're going to predict the weight of a sand shark whose length is 75 inches. And I actually want to do this the other way. There we go. Now I can see my equation. Y equals 4.35714x minus 156.143. Make that a little smaller so it fits. All right, so my R value was 0.9992. Again, that's right here. My R equals, not R squared, but R equals my R value. And the last thing I have to do is figure out, well, what's the expected weight? So they're saying, what if the length is 75? So again, length was my X value. So what we're going to do is we're going to take this equation and we are going to replace the X with the number 75. So notice I took my equation, 75 inches is the length, that's my X value, so I replaced it with 75, and now I'm just going to use a calculator to do the math on this. It's going to tell me what the expected Y value or the weight of the shark would be. All right, so now I have to go back to my calculator. Actually, yeah, you know what, let's use the Desmos calculator. So I want to show you how this works like a regular calculator too. I need to see those numbers. 4.357. You know what? It's actually right here. 4.35714 times 75 inches. I get it in the parentheses. And then I have to subtract 156.143. So I'm just taking this part of the equation and I'm putting the length in for X, so 75 inches, and that will predict the approximate weight. So how I want to use this now is all of our weights up above were given in whole number values. So we are going to round our answer here to a whole number. Notice I did not round the slope. I did not round the y-intercept. Those are the exact values that I get from Desmos because I want my line to be exact as possible. The only time you round is at the very end in your final answer. Because I have a 6 after the decimal point, I would actually round this up to the nearest pound. It would be 171 pounds. I guess I'm assuming it's pounds. And that's linear regression on a set of data. We use the graphing calculator to make a scatter plot of the data. We use the graphing calculator to find the exact equation for the line of fit and the exact R value. And then we could use that equation to make a prediction. We took this 75 inches, plugged that in for X. We just did a little calculator solving, and that gave us our expected weight for a sand shark.